Welcome to another Mathcast. In this episode we're going to be looking at using probability trees to diagram a probability problem. We're also going to be including a little bit of addition rule in this example, and it should be one of those examples that you really latch onto because this is a really good way of diagramming any sort of probability problem where you have multiple choices or multiple layers or multiple steps. I am, of course, referring to tree diagrams. So let's go ahead and look at the example that we have. College student chooses between two coffee places, Starbucks or the local place, Common Grounds, 20% of the time. And regardless of their choice, they're going to get a caramel macchiato 70% of the time. What I want to know is what is the probability the student goes to Starbucks or orders a caramel macchiato. So a couple of things that we want to look at here. First is the word or in the problem is telling me right away that this is going to be addition rule. Because it's addition rule, when I think of the events involved, I'll think of it this way. Let's let S be the event that they go to Starbucks, and not S would be that they're going to Common Grounds. I think that makes better sense to call this not S rather than to give it the name C, as you'll see here in a second. The other events involved are, I'll call this one capital C, and that's the event that the student orders a caramel macchiato. Hopefully I spelled that correctly. And not C would be obviously not a caramel macchiato. So what is the question asking us to do? It's asking us to find the probability a student goes to Starbucks or orders a caramel macchiato. So essentially the question is asking us to find the probability of S union C. That's what it's asking us to find. Now, that's maybe a little bit easier said than done when you consider that there's two different ways in which the student could order a caramel macchiato. One where they've chosen Starbucks and one where they haven't. That's what adds a little bit of a wrinkle to this problem. So let's try to start up a tree diagram here. Do my best to draw some straight lines for you. We'll do one more set of straight lines here. Alright, I know that there's two steps in this process, and I want to sort of outline each of the steps involved. Here's where we're going to start. And at the start, they can choose Starbucks or not Starbucks. And then the choice is caramel macchiato or not a caramel macchiato in each case. Now, that's just step one. All we've done is we've identified the nodes. Remember that these are called nodes. The next thing I need to do is I need to label my branches. The branches involved here first for Starbucks, this occurs 80% of the time. So that has a probability of 0.8. Remember, on a tree diagram, the branches for a single level must add to 1 for their probabilities. So since this is an 80% chance to go to Starbucks, it's a 20% chance that she doesn't, which is what it says here with Common Grounds being 20% of the time. And then finally, 70% of the time, it's a caramel macchiato, which means 30% of the time it isn't. Alright, same down here, 70% caramel macchiato, 30% not. Alright, at this point we have all of the branches labeled. What we need to figure out now is the probability associated with each of the different outcomes. So what I mean by that is, if you look, each branch represents a different outcome. This first branch represents S and then C. So this would be the probability of S and C for this outcome. Well, that's going to be 0.8 times 0.7. Remember, you multiply down the branches, which turns out to be 0.56 in this case. Here we would have S, then not C. So it would be S and no caramel macchiato. It would be 0.8 times 0.3. Remember, we're multiplying down the branches. For a total of 0.24, that's a 24% chance that that outcome occurs. Next is 0.2 times 0.7, which is not S and C. And that occurs 0.2 times 0.7 of the time, which is 0.14. And then finally, the last one here is not S and not C. And this occurs a very small percent of the time, only 0.06 or 6% of the time. Now, once we've done this, we've identified every single outcome that's possible. I do want to stress to you the importance of knowing what these individual branches are. This first branch is the probability of S. This is the probability of not S. Here, this branch, just this part, is the probability of C given S has already occurred. In other words, we've already chosen Starbucks. Now if I want to choose caramel macchiato, that's C given S. This one would be not C given S. This one would be C given not S. And then this one would be not C given not S. There is one other thing I want to point out here. Notice that the probability of C given S is the same as the probability of C given not S. That means that C and S are independent events. You probably could have figured that because it says regardless of her choice of coffee house. In other words, the choice of coffee house has nothing to do with her choice of beverage. But it's interesting to show how that plays out in the tree as well. All right, finally we want to answer our question here. So the question involved is the probability of S or C. I'll give myself a little bit more room here by erasing some of this in the top corner. And we're looking at the probability of S or C. By definition, that's the probability of S plus the probability of C minus the probability of S and C. Alright, the probability of S is really easy to pick out from the tree. It's 0.8. The probability of C is the one that is maybe a little bit tougher, but even it's not really all that bad. What should it be? Well, it should be 0.7. Minus the probability of S and C. Well, S and C is right here, is 0.56. So putting all of those together, you should end up with 0.94. Meaning that 94% of the time the student goes to Starbucks or orders a caramel macchiato. What's interesting is the only way that you couldn't get this result is if you went to didn't go to Starbucks and didn't order a caramel macchiato. That this is the complement of that event. If you look really closely down here, the complement is 0.06, which makes sense because this event was 0.94. These two are complements, so they should add to 1. Alright, I hope this has given you a little bit better insight on how to build the tree diagram as well as to label all the branches, pull out the important outcomes, and use that to actually answer a probability question. Thank you for watching.